A student investigates what happens when light travels from air to glass. So this is about refraction. Figure 2 shows some of the apparatus used in the investigation. So here we have a ray box producing an incident ray. That's an incoming ray because it's approaching a different medium, the surface of a different medium. So this is incident ray 1, and against the normal, that will produce angle of incidence I1. And then as it enters a more dense medium, which is glass, the light ray always refracts towards the normal, and therefore we get a smaller angle of refraction, 1, the first time it refracts. And then this ray is incoming against another surface or another change of medium. So this is incident ray 2, and what will happen is it will form another angle of incidence 2 against the normal, against its new surface, and then it refracts away from the normal, producing angle of refraction 2. So notice the pattern. The right light beam refracts towards normal as it enters glass and away from the normal as it leaves the glass. Also notice how these angles are the same, R1 and I2, and this angle are the same. So it says figure 2, angle Y, this one here, is the angle of refraction. Next it says the speed of light is 3 times 10 to the 8 meters per second. In other words, 300 million meters per second, roughly. The wavelength of yellow light is 5.8 times 10 to the minus 7 meters. These are very popular types of questions in physics exams using standard form and wave equations. Calculate the frequency of yellow light. State the unit and use the equation frequency equals speed divided by wavelength. So they've given you speed, they've given you wavelength, and you just want to work out frequency. This is worth 3 marks. The marks here don't come from rearranging the equation, you don't need to do that, but they come from processing the standard form, and you need to state the unit as well. So this is how I've set out this substitution of the figures into this equation. So you can see 3 times 10 to the 8 over there, which is speed, which is over here, divided by wavelength, which is 5.8 times 10 to the minus 7. But to do this, it requires 3 steps. Firstly, you deal with the numbers over here without dealing with the powers. Then you have to deal with these, the powers, and then finally you combine your results together. So those are the 3 steps you always take when doing standard form calculations and wave speed equations. So step 1, you deal with the numbers without the powers. So you just do 3 divided by 5.8, which is 0.52. I've done this to 2 significant figures. So that deals with this bit first. Next, you deal with the powers separately, so 10 to the power of 8 divided by 10 to the power of minus 7. When you're dividing powers, you subtract this one from this one. So 8 minus 7. And if you subtract a negative number, it's the same as adding it. So it's basically 8 plus 7, which is 15. A way I remembered it from school, if you think about it, these 2 lines become a positive. So now we've done this bit, so now we need to combine our answers. So if we look here, we've got 0.52 and we've got 10 to the power 15. So it's 0.52 times 10 to the power 15. Now the final mark comes from this, and this seems to be very, very popular at the moment. And I imagine on a higher paper, you will almost definitely have to do this. So if you look, it says 0.52 times 10 to the power 15. The problem is standard form has to be written between 1 and 9.9. It cannot be smaller than 1, and it can't be 10 or above. So it has to be between those values. So what we do is we move the decimal point here, or rather here, to make this 5.2. So we increase this by a factor of 10. But because the value now is 10 times bigger, we need to drop this power down by a factor of 10. So overall, the value is maintained. So by shifting this here, we drop this down by 1. Because this is increased by a factor of 10, so we must decrease this by a power of 10. And finally, you have to write the unit, which is hertz for frequency. If you want to do really well in a physics higher paper, whether it's triple or combined science, you must get familiar with these multi-part equations. But once you get these, it's almost guaranteed marks. It's just a process you have to follow, and it shouldn't be something you should be scared of. Okay, back to our refraction practical. So if we go here, figure 3 is a graph of the student's results. And you can see, always take time to look at the axes, the angle x is in degrees and angle y in degrees over here. So x here and y here. Use the graph to calculate a value for angle y divided by x. So you're working out a ratio here, y over x. So you just have to pick or determine a value for y. So if we look at this plot here, now look very carefully, it's halfway between two lines, so it's actually 13.5, not 14 or 13. So be very, very careful when you're reading graphs, because that's an important point. And obviously the angle x is 20. So all we do is 13.5 divided by 20 equals 0.7, and I've done that to one decimal place. The student concludes that angle y is directly proportional to angle x. Directly proportional means that you get a straight line relationship like this. Explain what the student must do to test this conclusion in more detail. So if we look at this graph, it does look like the beginnings of a directly proportional relationship, but obviously we need more data before we can confirm that. So where do the 3 marks come from? Well, firstly, you have to say repeat the experiment with more values of x, so we need more values of x, so we do it again with more values of x, and which are larger or at greater angles, so we're using small angles here and larger angles here. It's kind of a bizarre way to get 3 marks. I'd argue really this isn't a 3 mark question, but they've sort of eked out 3 marks from it.